Hello, it's Dr. Sherman. I'm going to outline the lab Archimedes Principle. In this lab, we're going to investigate the properties of fluids and buoyant force by analyzing free body diagrams. We're going to use and manipulate a simulation, and we're going to observe an experiment from a video and measure data from that video in order to graph and analyze the density. We're going to start the lab with activity 1, where we use a simulation to investigate buoyant force. The simulation we're going to use is the Density Lab HTML5 simulator, which is a simulation developed by the PhET team at UC Colorado Boulder. There are two ways that you can get to the simulation. One would be to go to the necessary equipment section of your lab assignment. You could also start directly from activity 1, and there's a link there as well that you could open. We want to start the lab using the mystery section of the simulation. What you'll see is a basin of water, the volume of that water, several different blocks of unknown weight and volume, and a scale. You're going to take these blocks, and some of them will sink, some of them will float, and you're going to draw free body diagrams of these different blocks. So after you determine the free body diagrams for objects in question, you're going to take each block individually. You're going to mass the block using the scale, and then you're going to drop the block by itself in the water and determine the volume of the water displaced by the block. From this information, you'll calculate the buoyant force on each block and compare them between the blocks. In the second activity, you're going to collect data from a video of a metal object being lowered into a graduated cylinder. From that graduated cylinder, you should be able to measure the volume of the water displaced by the metal object. From the video, you should be able to record the apparent weight as measured from a force sensor, the volume of the water as measured using the graduated cylinder markings, and from the initial volume of the water with nothing in the water, and each individual volume of the water with a portion of the metal in the water, calculate the displaced volume. In the experiment, there is an object being held by a string connected to a force probe. That force probe is measuring the apparent weight of the object. Now, if you look at the free body diagrams of an object fully submerged but not touching the floor of the vessel, the apparent weight can be shown by the weight of the object, or m times g, minus the buoyant force of the object, or the density of the fluid times the volume displaced times gravity. If we want to know the density of the fluid, we can take this linear equation and graph it. Let's look at our equation for apparent weight for a minute. I want this to be a linear equation. I need to think about what it is I'm going to change and what I can measure. As I lower the metal into the water, the volume displaced is going to change. So that volume displaced is going to be my x variable. I'm going to measure the apparent weight using the force sensor, so that is my y variable. As you notice, I had to rearrange my original equation a little bit so I could match my y and my x to the equation of a line y equals mx plus b. Knowing my x and my y then designates anything in front of the x as my slope, and anything that is added on to the equation as my y-intercept. This designates my y-intercept to be equal to the weight of the object in air. It also designates my slope to be equal to negative the fluid density times the acceleration due to gravity. So I'm going to plot my apparent weight on the y-axis and my displaced volume on the x-axis. I'm going to do a linear curve fit. I'm going to use that linear curve fit to find my slope, and from the slope determine the density of the fluid. If you have any questions on this lab, the preferred method to ask them is through the question forums. The reason for this is so that everyone in the class can see the question and specifically the answer to that question. The reason we want to do this is because it is likely that more than one person has that question. If you feel like it is a private issue, feel free to email your lab instructor using the instructor contact information posted at the top of the As You Learn page.